Hello students, how are you? I hope you are well and safe. Now, in this unit, chemical bonding. Previously, we discussed about the introduction to chemical bond. In this today's class, I will teach you about the ionic bond or electrovalent bond. So what is ionic bond? These questions might come in your mind. What is ionic bond? What are the energies involved in the formation of ionic bond? Which energies are there? Which energy favors the formation of ionic bond and which energy is against the formation of ionic bond? What are the properties of ionic compound? All these questions will be answered in this class. Today we will discuss all these topics. So let's come and study all of these topics. So students, in this class I will tell you about the ionic bond, or you can call it electrovalent bond. Ionic bond is also called as electrovalent bond, and this bond is formed between cation and anion. So primarily this bond is formed between cation and anion, and this is electrostatic force of attraction. So ionic bond is due to the electrostatic force of attraction between ions. So whenever there is a force of attraction between ions, we should say cation and anion. Then this is called as ionic bond. For the sake of your knowledge, let me tell you, the ionic bond is also called as electrovalent bond. So in this class, I'll give you the introduction of ionic bond. Then I'll tell you what exactly is the ionic or electrovalent bond. Then we will discuss the conditions for the formation of the ionic bond, which means under which conditions formation of ionic bond is favorable and what conditions are against the formation of ionic bond. Then there is a formation of ionic compounds, and then we shall study about the structure of some ionic compounds. Alright, so let's start this unit. See, what you see in front of you is the ionic bond. In this, one atom gives and another takes the electron to form the ionic bond. The atom which gives electron forms cation, and the atom which gain electron is called as anion, negatively charged, and this one is obviously positively charged. And because these are two unlike charges, there must be a force of attraction between them, technically called as ionic bond. So come, let us study some more points about the ionic bond. Like I said, ionic bond is also called as electrovalent bond, So a chemical bond is formed by the transfer of electron from one atom of an element to the another element, different atom. And like I said, this will cause the formation of cation and anion, and the attraction between them is ionic bond or electrovalent bond. See, the formation of an ionic bond involves formation of cation and anion. So which energies are involved in this? Which steps are involved in the formation of cation and anion? Now we shall discuss further in this class. First of all, we will discuss about the formation of cation. In order to form an ionic bond, we need cation. The elements having 1, 2 or 3 electrons in the outer shell. So if suppose any element is having 1 electron or say 2 electron or say 3 electron in outer shell, then what will happen to gain the stability? As we know, in order to gain the stability, there should be 8 electrons in outer shell. So now there are two possibilities. Either they will gain 7, 6 or 5 electron, or they will lose 1, 2 or 3 electron. So it is quite difficult to gain 7, 6 or 5 electrons rather than losing 1, 2 or 3 electron. So those elements which have 1, 2 or 3 electrons in outer shell, they have tendency to lose electron, and as a result they convert into positively charged species called as cation. These cations are simply formed by the loss of electron. So here is the loss of electron. Which energy is involved in the loss of electron? Obviously the energy which is involved here is it is ionization energy which is required for the sake of ionization. And those elements which have loose electrons, means the electron which can be separated out easily, they are electropositive element. Obviously they are electropositive elements, means they can lose electron very easily and they attain positive charge very easily. So they are electropositive, right? Here is the example. What do you see in front of you, students? There is a in front of you there is a sodium atom in which 11 protons are there and 12 neutrons are there. In the nucleus of sodium, see, 11 proton and 12 neutrons are there, and 11 electrons revolving around these 11 proton and 12 neutron, which is nucleus. And the species is, for now it is neutral. For now this species is neutral because number of protons are 11 and number of electron are also 11. So they are quite equal and effectively there is no charge. The overall species is neutral. But if you have a look at sodium +1, what happens in sodium +1? See, this electron of the outer shell, it has been removed. When this electron has been removed, remaining there will be for 11 proton there will be just 10 electrons, and this will cause formation of the cation Na+. So then there will be a formation of cation Na+. Alright, so here is the formation of cation Na+, which is required for the formation of ionic bond, because this cation will further participate in ionic bond formation. How this will further participate in ionic bond formation? Now we shall see the another counterpart, which is formation of anion. Now what happens with the anion? What is the anion? Anion is negatively charged species. Those species which have 6, 7 or 8 electrons in their outer shell, they have tendency to gain electron rather than donating electron, because in order to complete their octet, these species will have to donate 5, 6 or 7 electron, which seems quite difficult. So rather than donating 5, 6 or 7 electrons, they have tendency to accept 1, 2 or 3 electrons, and by which they form anion. So they are negatively charged species called as anion. These elements whose atom accept electron easily and form anion, they are electronegative elements. So what are the electronegative elements? Those species who gain electron very easily. Alright. Say for example, chlorine is there in front of you, my dear students. You see, in the neutral chlorine atom, this is neutral without any charge. How many protons are there? Say 17. And how many electrons are there? Again 17. That is the reason why there is no charge over the chlorine atom. But what happens when it forms Cl-? See, you see this green color electron? This green color electron is additionally gained in this species, so that proton are still 17, but now electrons are 18 in number. So in totality, -1 charge is there. So now species is Cl minus, which is anion, right? So now we came to know that for the formation of ionic bond, we need cation and also anion. In order to form the cation, what you have to do is to remove electron. In order to remove electron, you need ionization enthalpy. So lower the value of ionization enthalpy, easier will be removal of electron and greater will be the tendency to form cation and also the formation of ionic bond. So now we came to know the final conclusion of this is lower value of ionization enthalpy. Students, please listen me one more time. It is important. Lower value of ionization enthalpy, low value of IP is in the favor of ionic bond formation. Why? Let me tell you one more time. If IP, ionization energy, will be low, if it is easy to remove electron, cation will be formed easily. If cation will be formed easily, there will be formation of ionic bond easily. Then the next energy which is involved here is the electron gain enthalpy. Students, do you remember? Do you know what is electron gain enthalpy? You studied about the electron gain enthalpy in the class 11th. In the chapter periodic table, I told you electron gain enthalpy is the involved amount of energy when electron is added to an isolated gaseous atom. For most of the species, this energy is released energy, or you can say yes, it is negative energy because the process is exothermic. So when you try to add any electron in the electron negative species, say for example Cl, if you want to form the ionic bond, you need to convert this Cl into Cl minus. In order to convert Cl into Cl minus, you need to add an extra electron. When you will try to add an electron in the chlorine, there will be involvement of the electron gain enthalpy, and as we know, as far as the chlorine is concerned, it is highly electron negative element and its electron gain enthalpy is not only higher, it is just highest in the entire periodic table. So if higher is the value of electron gain enthalpy, electron will be added to the anion very easily, and of course it will be in the formation of ionic bond. So we also conclude this, that higher value of the electron gain enthalpy is in the formation of ionic bond. Then the third energy which is involved here is the lattice energy. Now what about the lattice energy? Do you know what is lattice? It is three-dimensional arrangement of the you can say crystals or compounds or the ionic compounds or the metallic compounds. So whenever any ionic bond is formed, basically there is a formation of ionic lattice, and whenever there is a formation of ionic lattice, energy is released called as lattice energy. So higher the value of the lattice energy, greater is the ease of formation ionic bond. So now we have three energies which are engaged, which are involved in the formation of ionic bond. Number one is ionization enthalpy, number two is electron gain enthalpy, and number three is lattice energy. And what values of these energies are in the favor of ionic bond? In order to form stable ionic bond, if we need to form stable ionic bond, this IP should be low. This ΔHEG, which is electron gain enthalpy, should be high, and of course lattice energy should be high. Or you can also say, because this energy is exothermic, so yes, I can say for the formation of ionic bond, I can say this, formation of ionic bond, total exothermic energy should be greater than total endothermic energy, because if energy is released, it will bring extra stability to the molecule, right? So here is the ionization enthalpy. Here is the detail of the ionization enthalpy. Like I told you, what is the ionization enthalpy? Ionization enthalpy or ionization energy is the minimum amount of energy required to remove an electron from the isolated gaseous atom. So like I said, it is the absorbed energy. Here delta H is positive. It is endothermic. And the energy which is absorbed during any process will destabilize the system, because stability is always inversely proportional to the energy. So we need value of this energy to be lower side. It should be on the lower side. Now the next is electron gain enthalpy, or previously it was called as electron affinity. So this is what? This is the amount of energy released, like I said, exothermic, when it is released on addition of an electron to a neutral gaseous atom. So whenever you try to add an electron in the neutral gaseous atom, there is a involvement of the energy, which is released energy, is electron gain enthalpy or electron affinity. Alright. Third one is the lattice energy. Again, we are discussing this. What is lattice? It is three-dimensional structure of the solid ionic compound in which cations and anions are present. Whenever any lattice is formed, some amount of energy is released. And of course, when you will try to dissociate the same lattice furthermore, then the same amount of energy will be required to dissociate this lattice. So higher the value of the lattice energy, greater is the ease of formation of ionic bond and stable lattice. Higher the lattice energy, stable will be the lattice. So higher value of lattice energy is in the favor of the formation of ionic bond. So I hope now you are getting which factors and which energies are involved in the formation of ionic bond. Here are some examples of the ionic compound, like magnesium chloride, like calcium oxide, like potassium bromide, like sodium oxide, like aluminium oxide, and also like magnesium oxide. See, here I would like to ask you one question. How you will call this compound? What should be the name of this compound? Students, this compound is named as carbon tetrachloride. But what about MgCl2? Do you ever call MgCl2 as magnesium dichloride? Do we call it like this? No, we don't. We don't call it magnesium dichloride. Rather than calling it magnesium dichloride, we simply call it magnesium chloride. So why you are not calling it magnesium dichloride, like you was calling CCl4 as carbon tetrachloride? So here you are using the term tetra, but here you are not using the term di. Here it is correct, but here it is wrong. My question is why? And the logic is, this compound is covalent in nature. There is a separate nomenclature. There is a separate nomenclature in the inorganic chemistry given by the IUPAC, International Union for Pure and Applied Chemistry, for the nomenclature of inorganic compounds. Like the organic compounds, we also have nomenclature of inorganic compounds. Alright. So how these ionic compounds look like? What is the structure of the ionic compound? Ionic compound exists as crystalline solid. So they do have crystals and also they are solid. And the ions present in the ionic compounds attract the positively charged species. Means positive will attract negative and negative will attract positive. Because these ions are uniformly distributed in the electric field. And these ions are arranged in such a way. Please listen me one more time. These ions, which ions? Cation and anion. They are arranged in such a way that every positive ion is surrounded by some certain definite number of the negative charged species and vice versa. Means negatively charged ions are also surrounded by some definite number of positively charged species, and this happens in the close packed structure called as crystal of ionic compound. So when you arrange the cation and anion in the regular fashion, there is a formation of lattice or the crystalline lattice, ionic lattice, which is obviously a three-dimensional structure. This is not in 1D, it is not in one dimension, it is in 3 dimension, right? Like this one. Students, the picture you see here is the lattice of NaCl. You can say NaCl crystal. Here in this, these green color atom, they represent chloride ion, Cl minus ion, and these small violet color atoms which are placed at the center of edge of each unit cell and also at the body center of unit cell are representing sodium atom, and this entire is the crystal or unit cell or lattice of NaCl, in which there is an attraction between the positively charged ions like sodium plus and Cl minus. So those species which are opposite in charge, they will attract each other, and this attraction keeps them together, and this is one of the primary reason of the stability of ionic compound. Now we shall discuss further about the ionic compound. These are 3 energies which are involved here: electron gain enthalpy, the energy which is released in the formation of ionic compound; ionization energy, which is required absorb energy; and lattice energy, again, which is completely released energy when 1 mole lattice is formed. This energy could be absorbed energy also if you are trying to break the lattice, but here in the ionic compound we are not breaking any lattice, we are forming the lattice. So it is required energy when you separate ionic compound into the constituent ion, and when the constituent ion they combine together and then they form the ionic lattice, then this energy is not required. In that case it is released energy. So these are some energies which are involved in the formation of ionic bond formation. Now we shall discuss about some properties of ionic compound. What properties ionic compound have? So now we are discussing properties of ionic compound. Here are the following properties of ionic compound. Number 1, they have high melting point and boiling point in comparison to the covalent molecules. Their melting and boiling point is pretty high. They are soluble in, ionic compounds are soluble in polar solvents. Any example of polar solvent? Here it is H2O, and they are almost insoluble in the non-polar solvent. Moreover, ionic bond is non-directional, so ionic compounds are also non-directional, means no geometry. See, in the coming few classes you shall see that covalent compounds, they do have geometry. Sometimes it is tetrahedral, or it is square planar, or triangular bipyramidal, or whatever. There are so many different shapes and geometry. But covalent compounds, they have shape and they have geometry as they form bond in the certain direction. But ionic compound bond is completely non-directional. So there is no shape, there is no geometry for the ionic compounds. Moreover, ionic compounds are brittle in nature. Do you understand what is the meaning of brittle? Those who can you can bring that down into pieces very easily. Even if you apply a very small amount of force, it will break down into the several pieces. Such compounds are called as brittle. As in the ionic compound we have you say ionic layers, layer of cation, layer of anion. On applying external force, these layers, they slide over each other, and because of this sliding process, sometimes similar ion come in front of each other, which causes a great repulsion, and due to which ionic compound splits into the smaller pieces. So it is brittle in nature. And last but not the least one, ionic compounds, they do not conduct electricity. They do not conduct electricity in solid form. They do not conduct electricity in solid form, but can conduct electricity in their aqueous solution, in the water, or molten form. Because in the molten form or in the water, their ions are supposed to move in any direction. They are free to move. Alright. So these are some properties of the ionic compound, and this is all about the ionic compound. In the coming classes, we shall see further units of this chapter, further fundamentals of this chapter, chemical bonding, and we will keep this class up to here only. Thank you so much for staying with us. Please keep studying and keep coming. Thank you.